Okay, here's a video on graphing rational functions with restrictions and restricted values. So just a couple of vocabulary things. Vertical asymptotes are where the denominator of a function is equal to zero. So we can't divide by zero. You can't, make groups of zeros so that those two things keep each other from happening. So anything that would make your denominator of your function zero, that's going to cause a vertical asymptote, which is a vertical line, imaginary line of values that are excluded from your domain. A point of discontinuity, so that's just one point that you don't use, not an entire line. We call those holes, and I'll talk a little bit about where those come from here in a second. All right, so just to get us started here, we're looking at an example one, and in example one here, what we have to do first to determine if there's going to be any vertical asymptotes is we're going to need to go ahead and factor the numerator and denominator of this function. All right, so let's go ahead and do that. All right, the top, x squared minus 1 is the difference of two squares. So that's going to factor as x plus 1, x minus 1. And now my bottom is a trinomial, and I can do the factors of 5 that add up to negative 6. Well, that's going to be x minus 5, x minus 1. Okay, so we've got them factored. Now at this point I can look to try to simplify. I've got two factors on the bottom, both of which could make the denominator 0 if x was equal to 5 or if x was equal to 1. But paying really close attention, I've got an x minus 1 on the top and the bottom. So I actually can cancel those out, simplifying because they're being multiplied. And whenever I cancel out a factor, that is an indication that we have a whole. So we're going to have a whole when the x value is positive 1. Because if I solve x minus 1 equal to 0, x would equal 1. But remember, a whole is a point. So I have to take that 1 and plug it back in. So really quickly, what's left over is this x plus 1 over x minus 5. So if I real quickly plug a 1 in there, that'll tell me what the y value is that goes with this x value of 1 for my whole. So that's 2. 1 minus 5 is negative 4, so negative 1/2. So I have a whole at 1 negative 1/2. That would be where my whole is, or my point of discontinuity. Very important that you understand that a whole is just one point and that an asymptote is an entire line. All right, so we've just determined what was left over is going to be x plus 1 over x minus 5. And the only value of x that would make my denominator 0 would be 5. So we have x equals 5 as a vertical asymptote. Okay, so again, we simplified, we factored, then we simplified, and what was left over, then we concentrated to help us figure out what the vertical asymptote was. The factors that canceled gave us the x value of the whole. We plugged that back in to get the y value for my whole. All right, let's try that one more time. We'll go scoot over here to the second example. Again, our first step is going to be to factor. X squared minus 4 is the difference of two squares, x plus 2, x minus 2. And then the bottom, x squared plus 5x plus 6, we can factor that as the factors of 6 that add up to 5, which would be x plus 2, x plus 3. All right? Now, we see that we've got x plus 2 and x plus 2 that would cancel because they're the same, top and bottom. So that's going to indicate that we're going to have a whole at x value of negative 2. So I got to figure out what the y value is. So I'm going to substitute in for what's left over. So negative 2 minus 2 on the top and negative 2 plus 3 on the bottom. I'm just substituting in for that x value. Negative 4 over 1, which is negative 4. So I have a whole at negative 2, negative 4. So that's that one point of discontinuity. Now what was left over in pink x minus 2 over x plus 3. The only value that would make my denominator 0 would be negative 3. So that means we have a vertical asymptote at x equals negative 3. Again, negative 3 would make my denominator 0. So that's why it's x equals negative 3 for my vertical asymptote. So that's an entire line of discontinuity, meaning there's not going to be a single point who has an x value of negative 3 in this function. All right, so that's how we're figuring out holes and vertical asymptotes. Let's take a look at this chart right here, and it'll talk to us a little bit about determining horizontal asymptotes. So some important information for you here, and feel free to pause the screen at any point and write this down. But horizontal asymptotes is where you compare the degree of the numerator and the degree of the denominator. Remember that the degree is the highest power. All right, so the degree of the numerator and the degree of the denominator is what you should kind of identify right away. And then this chart helps us to understand. Now, for the purposes of the chart, m is the degree of the numerator and n is the degree of the denominator. All right, and then here, here, and here, and just to make sure you could see that well, this is m equals n. These are our three scenarios with our numerator and denominator. So if the degree on the top is less than the degree on the bottom, that's what we got this first scenario here. The degree on the top is smaller than the degree on the bottom, then it's an every single time horizontal asymptote of y equals 0. So regardless of what cancels out, regardless if we have asymptotes or holes, if the degree of the numerator is less than the degree of the denominator, we have a horizontal asymptote at y equals 0. All right, this next scenario says, okay, if the degree of the top and the degree of the bottom are the exact same, then all we do is we take the coefficient of the highest term on the top and divide it by the coefficient of the highest term on the bottom. So important that you want to put the numerator and denominator in standard form so that they're in order from the highest power down to the lowest power, so it's easy for them to line up. So in this situation, our lead coefficient on top is a 1, and our lead coefficient on the bottom is this 4. So we would have a horizontal asymptote at 1 over 4. So y equals 1 over 4. Okay, that's when the numerator and the denominator have the same degree. All right, and then our third scenario is if the top degree is greater than the bottom degree. So that means the highest power on the top is bigger than the highest power on the bottom. Well, if the highest power on the top is bigger than the highest power on the bottom, then there is no horizontal asymptote. So in this case, x squared on the top, x to the first on the bottom. The highest power on the top is a 2, highest power on the bottom is a 1. Top is higher than the bottom, therefore no horizontal asymptote, none. So that's how we would handle that. So we factor, we simplify, we cancel to try to figure out holes, and whatever's left over in our denominator, that would indicate vertical asymptotes. We use the degree of the polynomial to figure out horizontal asymptotes. So what you really want to make sure that you're doing is you're paying attention to, first things first, what's the degree of the top and the bottom? Then you can determine any horizontal asymptotes. After that, I would go ahead and factor, cancel, and what was left over indicates what your asymptote or your vertical asymptotes might be. Okay, I'm going to do a couple of examples with you down here, and we'll finish up. All right, so what we're going to do down here is we're going to try to just do the whole process. Now, I'm not going to graph it with you. You can use your graphing utilities, calculator, Desmos is really great. I'm just really going to concentrate on the algebra part of this for right now. So what we're going to do first is determine if there's any horizontal asymptotes. All right, and the way that we do that is determine the degree of the top and then the degree of the bottom. So the degree of the top is 2, and the highest power on the bottom appears to be a 1. So y equals, because it's a horizontal asymptote, 2 over 1, which simplifies as just 2. So we have a horizontal asymptote as y equals 2. Then I'm going to go ahead and simplify by factoring and seeing if anything cancels out. So the top, I can factor factors of -2 that add up to +1. So that looks like x plus 2, x minus 1 are my factors on the top, and I've got x minus 1 on the bottom. So that's an indicator that these are going to cancel. So that's what a hole, they're going to have a hole there. So we will have a hole when the x value is +1. I've got to figure out what the y value is. So when I cancel those, all that's left is this x plus 2. So I'm just going to substitute in for that x and that x plus 2. So y equals 1 plus 2, again, because that's all that's left in that function, which is going to be 3. And that's going to go into my y value. So I've got a hole at 1, 3. Now, again, the function that's left over is f of x equals x plus 2 because we canceled out the x minus 1s. So because there's no denominator, there's not going to be any numbers that can make the denominator 0. So there are no vertical asymptotes. So that's how we do that. We're going to do one more example over here. But again, pause your screen and rewind if anything needs to be repeated for you. Again, no vertical asymptotes because there was no denominator after we canceled out. All right, here we go. Last one. Real quick, to figure out my horizontal asymptotes up here, what we need to do is figure out the degree of the top and the degree of the bottom. Degree of the top is 1. Degree of the bottom is 2. So that's going to be y equals 1 over 2. All right, now I'm ready to simplify by factoring. X minus 1 on the top. X squared minus 1 is the difference of two squares, so that's going to factor as x plus 1, x minus 1. And my x minus 1's canceled, so I'm going to have a hole when my x value is +1. So that's going to leave me with y equals, and we have to have a placeholder on the top, can't just leave it blank, 1 over x plus 1, and instead of that x, I'm going to put a 1. So that's 1 over 2. So my y value at 1/2. Well, we already knew we weren't going to have any y values of 1/2, and so that hole just happens to be on that horizontal asymptote. It doesn't always work out like that, but it does in this case. So then to figure out my vertical asymptote, I keep in mind that my remaining function f of x equals 1 over x plus 1. The only number that can make the denominator 0 would be if x was equal to -1. This is my vertical asymptote because that's the one place that would make my denominator 0. Okay? So use your graphing utilities to confirm these things always and to help you sketch accurate graphs. But this is how you figure out your horizontal asymptote, your holes, and your vertical asymptote, all places of restrictive values and discontinuity.